Good afternoon to everyone, and welcome to this event organized by the Italian National Center for Sustainable Mobility, or we like to call it MOST. I'm Claudia Simoni, I'm the Business Development Manager, and it's a real pleasure to to open this event today at the Italian Pavilion. Let me start by wishing you a peaceful and a joyful Easter Sunday. It's a special day to reflect, connect, and look ahead with hope for our future. As the claim of Osaka Expo is designing better future society for a better lives. Also, MOST, we would like to design future mobility for better lives. This afternoon, we'll explore how research is driving innovation in mobility solution, and how these results are already making impact in people, cities, and industries. I don't want to take any further time because we have many speakers and I would like to leave their room. So let's begin with our first speaker, Gianmarco Montanari, General Director of MOST, who is joining us remotely. And he will present the strategic and the vision of the National Center.
Thank you, Claudia. Thank you, everyone. Dear guests, good afternoon and happy Easter greetings. It's a great pleasure for me to welcome you, albeit virtually, to the event MOST at Expo Osaka, from research to business. Being present at Expo 2025 in Osaka represents not only a significant milestone for the National Center for Sustainable Mobility, but also a unique opportunity to share with the world the outcomes of our joint research between universities and businesses. We are here not only to present our results, but also to look ahead, to begin new collaboration, joint research, and shared innovation pathways with partners from around the world. Launched in June 2022, by the initiative of the Italian Ministry of University and Research and funded under the Next Generation EU program, MOST is the result of collaboration among 24 universities, the CNR, and 24 major companies, mostly listed in Italy. Over the past 3 years, we have built a national innovation platform that integrates scientific research, industrial development, and strategic vision. Today, in a global context where sustainable mobility is at the heart of urban industrial policy, MOST stands as a reference model offering concrete and innovative solutions. Our work responds to key trends such as accessibility, reliability, safety, and sustainability in the mobility of the future. In the coming hours, you will have the pleasure to hearing from our spoke leaders, researchers, and other key figures involved in our project. They will present innovation ranging from sustainable and road vehicles, such as prototype of an adaptable motor with shapeable batteries for lightweight urban electric cars, to regenerative suspension system and more. In the maritime field, we will discover Elettra, the catamaran developed under the Uniboat project, powered by an electric battery and hydrogen fuel cell and solar panel. You will also hear about having digital mobility platform like Optifast and cutting-edge hydrogen propulsion technologies. This project not only shows the excellence of the Italian research, but also directly address the global challenges of the energy and digital platform. For example, the growing attention to lightweight electric vehicles and mobility solutions reflect the urgent need to reduce emissions and improve quality of life in our cities. In closing, I would like to thank all the partners, institutions, and researchers who make the success of MOST possible. Our presence at Expo 2025 in Osaka is the proof of a shared commitment to a more sustainable and innovative future. I wish you an event filled with insights and inspiration. Thank you for your attention. Arigato, grazie e buona Pasqua.
We now can see the contribution of Giovanni Donato, Diplomatic Advisor of Ministry of Infrastructure and Transport, and he will share an institutional greetings from the Italian government.
Buongiorno Osaka. I am particularly glad to address such an outstanding event hosted by the Italian Pavilion and devoted to transport policies. Let me first of all express my congratulations, also on behalf of Minister Salvini, to the Italian Commissioner, my dear friend Ambassador Mario Vattani, and the President of MOST, Professor Ferruccio Resta, and his team for the brilliant job they are carrying out today. As you probably know, transport infrastructure and the future of mobility are the two main areas of the Italian Pavilion visitor experience. In the video, which is part of the visitor experience, we have displayed only some flagship projects of our main program of infrastructure investments. The two railways-based tunnels bridging the Alps, Torino-Lione from France and the Brenner-based tunnel from Austria, which will allow people and freight to cross the Alps in the fastest and most sustainable way. We have included also two main water infrastructures, the new breakwater making the port of Genoa able to harbor the largest ships in the world, and the MOSE, the innovative system of mobile gates protecting Venice and its lagoon from flooding. There are some of the most relevant railways projects, such as the new bypass of Florence and the new high-speed lane connecting Naples to Bari. When it comes to local and regional transportation, you can see the new metro station of Piazza Venezia in Rome and the hydrogen project connecting the Val Camonica area. Last but not least, the bridge over Messina Strait and the infrastructure for the 2026 Winter Games of Milano Cortina. Our main goal is to show what this government is doing, not only to pave the way for a more modern, innovative and sustainable transportation network, but also to revamp Italy's engineering and management long-lasting tradition in the field of transport infrastructure. This is why, on behalf of Minister Salvini, I would like to acknowledge once again the importance of today's event and the brilliant job MOST is carrying out to call the attention of experts and visitors on the role of transport and infrastructure in designing future society, which is the overarching theme of Expo 2025. All the best and have a fruitful meeting.
For the center, it's really important to have the support of the Italian institution for our effort that we are doing in research and in improve the mobility solution. I am now pleased to invite Simone Passeri, economist at Cassa Depositi e Prestiti. He will offer a look at macroeconomics and geopolitics scenarios impacting the future of mobility.
Thank you, Claudia. I'm an economist, not an engineer. I work in Cassa Depositi e Prestiti, the Italian national promotional institution. I will talk about CDP later, and now it's a big pleasure to be here today and a great opportunity I'd like to thank MOST, Director Montanari, Claudia, and Christian for the kind invitation. And I really appreciate the work that MOST is doing in Italy in the last years. In a few years, MOST has become one of the main players in our country's mobility landscape. And so as CDP, I am very happy to be here with you. So this is the outline of my presentation, sorry. In the first part, I'm going to give you a general picture of one of the main challenges of transport, that is the decarbonization. And in the second part, I will focus on the role of finance in supporting the ecological transition and on the CDP's contribution. So let's start by saying that Europe is a front runner in climate action. You know that in late 2019, the European Commission launched the European Green Deal and set an ambitious goal of achieving carbon neutrality by 2050, and later the EU added some intermediate targets. But overall emissions have dropped by 28% compared to 1990 levels. However, if we look at transport is the only major sector in which emissions have risen by 26%. So this gives us the why it's important to talk about decarbonization. Transport, you know, generates more than a quarter of the EU greenhouse gas emissions. This share is projected to rise up in the next year. Road transport is the main responsible for transport emissions, however, if we look at the last 30 years, the biggest increase is in international aviation, domestic aviation, international shipping. So any decarbonization strategy should consider as a priority the reduction of emissions in road transport, but we have also to look at the aviation and shipping sectors. How can we decarbonize our continent? A widely used paradigm is the ASI framework, avoid, shift, improve. Avoid means reducing the need for travel, and that can be achieved through better urban planning and digital alternatives like remote working or online services. Shift focuses on promoting sustainable transport modes such as public transport, cycling, walking, and improve means making all transport modes more efficient and cleaner, so through electrification, technological innovation, and the use of low emission fuels. So innovation is key in this context. Identify 4 fields of intervention, so fleet electrification, smart infrastructure, alternative fuels, and digital solution, and many others that we will see today. But I think that innovation is for a researcher and university. I can talk about finance, resources, and investments. And you know that the scale of the investment required is very, very large. There are many estimates about that. This is from transport and equipment and environment, sorry, but also the commissions said that in the next decade, our needs of investments are about 500 billion euros, about 37% increases compared to the previous decade. So it's a great challenge. It's interesting to note that according to these estimates, the great part should come from private sector, 87%. The public sector plays a limited role in moving resources, in mobilizing resources, but at the same time, its role is very, very crucial to boost investment, increase manufacturing capacity by leveraging private resources and risk more risky projects. So this is one positive example of how EU is managing the transition in the transport sector, the case of batteries. And batteries, you know, is strategic for both the clean energy shift and the competitiveness of the EU automotive industry. In the chart on the left, you can see the production plants existing, under construction, or announced by the EU, and we are on track to reach over 100 gigawatt hour by 2030. That is more than enough to meet the future EU demand. How is this possible? Because EU showed a strong commitment for the building of the supply chain. I think the European Battery Alliance, the publication of a strategic plan for batteries, the European Critical Raw Materials Act, and EU used a lot of EU budget program to sustain this supply chain. In these slides, I reported some example. The Innovation Fund, that is one of the largest funding program for clean tech in the world, and InvestEU, that is a guarantee system, EU-backed guarantees to reduce the risk of capital-intensive projects, loans, guarantees, co-financing and credit lines from the European Investment Bank, and lastly, the IPCEI, the important projects of common European interest that are cross-border projects financed by national budget and with relaxed aid-stead normative. Two IPCEIs have been launched in the last years for batteries. And let me to conclude about CDP and its role for sustainable mobility. Just a few words about CDP. CDP is a financial institution, 107 years old, with a strong public mandate, because the main shareholder is the Ministry of Economy and Finance in Italy. And CDP must support the sustainable development of our countries. And how do we do that? We collect retail saving and we use them to finance important projects, infrastructure, large industrial projects, support the public administration and also the SMEs. And we operate in all strategic sectors, and especially in those sectors in which there are market failures. And so, in our strategic plan of the previous three-year horizon, 2022-2024, we identify 10 fields of intervention that have been confirmed in the new plan that is more engaged on sustainability, also in this geopolitical context. Among these fields, I highlight the energy transition and transports and logistic nodes, but it's important to highlight also digitization and technological innovation, support to strategic supply chain. And among our goals, there are, for example, the electrification of energy consumption, and so to support the deployment of charging infrastructure, or the renewal of clean bus fleets. And another goal is the promotion of urban mobility, both enhancing the modernization, the rail infrastructure, or the digitization of local public transport. In the last slide, I reported some example. So on the left side, you find the main tools of CDP. We operate through a wide set of financial tools: loans, direct loans to companies with long maturities, substantial amounts, but also indirect loans through the banking system, guarantees to the risk projects, equity, and also technical assistance and advisory. Technical assistance and advisory also for technical project through a wide range of engineers, from the feasibility assessment of the project to the guidance on planning and implementing and monitoring the projects. So some operations, we are active in equity through CDP Equity. We are the main shareholder of important players of the transport sector, such as Autostrade per l'Italia, the Italian company specialized in the management of motorway, and Fincantieri, one of the largest shipbuilder in Europe. We operate also on the infrastructure side. We financed the strategic plan of Autostrade per l'Italia, but also the renewal and the modernization of the railway between Catania and Palermo in Sicily, in the south of Italy. A great operation that takes around 3 billion of euros with the support of European Investment Bank and Intesa Sanpaolo, and under the framework of the InvestEU program already cited. And so we operate also in the public transport at level local. So we finance the renewal of an important regional operator such as Tiper in Emilia-Romagna. And we also operate in the innovation field through CDP Venture Capital, who helps startup and scale up to grow and to boost innovation. An example is the capital increase in Refilla, that is a startup that are developing energy storage and mobile power generation solution. So these are only some example of our activity that is very huge. Our effort is significant, and in line with our mission, we will continue to support the transition of the transport sector towards a more ecological, innovative, and inclusive model, and covering the entire value chain, so from infrastructure to services and industry. To conclude, I think that this event is very important because are represented all the actors necessary to boost the ecological transition in the transport. So innovation, researcher, university, research center of large companies. Without technologies and new ideas, the transition will be very difficult because of the growing demand in the sector. Investment, and so the role of CDP and the banking system and the EU program to sustain the entire value chain from the research stage to the deployment and the commercialization of the technologies. And finally, the involvement. In this case, it's fundamental the role of MOST. MOST is a collector of energy, resources between governments, businesses, universities, and so I think it's very important, its work, and I'm here to confirm the sustain from CDP. Thank you very much.
Thank you, Simone, for your clear and insightful presentation on the context of mobility solution. Now we welcome Paolo Malighetti, professor from University of Bergamo and a spoke leader at MOST. He will reflect on the strategic role of research. Paolo, the floor.
Hi, good afternoon. I'm Paolo Malighetti. I'm a management engineer, so we are moving a little bit from economics to management engineer, and finally we'll reach also the technical stuff. So the title of the presentation is quite challenging because strategic role of research. I believe that the majority of people that are here are researchers or work in research, or they strongly believe in research. So probably there is no need to say anything. By the way, since they give me this duty, I will try to do some reflection. Starting from a technical aspect. Research innovation is a key for competition. And in the last 10 years, Europe basically lagged behind US and China. And one of the reasons it is that the level of the investment in terms of share of GDP it was far lower compared to the other two areas. And for this reason, we are not late, but at least we feel the perception to be late. Second key aspect from the general point of view, it is that in the last 10 years, and even before, we saw the rising of what we call the mega corporates. And nowadays, the first 10 mega corporates invest in innovation more or less like a medium or well-developed country. So if you see Alphabet, they invested 40 billions per year in innovation. If you consider 2% of GDP invested in innovation for Italy, it's equal to 60 billions. So Alphabet is close to Italy in terms of annual investment of GDP. So we need to work in an environment in which the reference is firms that are bigger as a country. And MOST is one of the answers. We will see in the next slides that one of the reasons because an initiatives like MOST have sense, it is because it's better fit with the new environment. I don't want to, let's say, list all the other shocking events that happened in the last 2-3 years since MOST existed. But of course, the world is changing rapidly, even shocking in somehow. And for this reason, last year in 2024, the European Commission tried to identify guidelines for fostering the European competitiveness. And among others suggestions, there was 3 aspects that is connected to research. First one, to meet a target of 3% investment of GDP in innovation in order to be competitive also in Europe. In order to Europe to be competitive to the rest of the world. Second, the fact that we need to approach to science in a systemic way, and also to take what we call the societal challenges. Third one is try to fully exploit the potential of the partnership between public and private, because no one of them is enough, at least in Europe. All this aspect is particularly true for transport. Transport is an important part of economics, so this aspect applies to transport because transport itself accounts for about 6% of GDP in terms of direct contribution to the GDP. But moreover, transport is an enabler of a lot of other sectors, industries, like tourism, for example, but not only tourism. Having a good logistic is a key for a series of other industry, like technological industry, etc., etc. We estimate that if we account also for this effect, the impact of the transport more than doubled compared to the 6% direct GDP. As already mentioned in the previous presentation, transport is one of the industry that was not able to decrease the level of emission. Not because transport is less developed than all the other sectors, but because the need for the demand for mobility is continuously increasingly. So when we say that transport is not reducing CO2, it doesn't mean that we are not accounting for innovation, we are not decreasing the impact of a single movement. It means that alongside this evolution, we also observe more than proportional demand of new mobilities. So we need to take into account this fact, that when we call green transition, we are talking about meeting targets with no detrimental effect on society, with no detrimental effect on economy, so with no detrimental effect on the demand of mobility. And likely for us, people love It's a part of our life, it's a part of the economy. If we don't move, the economy drop. So that's a key, and we need to account for that. Typically, we talk about green transition. In the next hour, we will see that only most we take a lot of aspects regarding mobility. Changing in the propulsion, but also automation. So green transition is a limited word for what we are observing. So we need to acknowledge that we are not in a transition. We are in a revolution. So it means that when we picture the future for the mobility, everyone has probably seen also in our videos a futures that we imagine in which every car moves autonomously. There is no, all the sources of energy are green. There is no accidents. All these aspects can happen, but if we took all together, that means that what is going to happen is a revolution, not simply a translation. We need to change the technology, we need to change the behavior of the population, and all these changes affect everybody, not just a part. So everybody should be aware about this transition, everybody should know which is the effect, everybody should know what they are going to. And this is complex to be reached. That's why somehow we heard about, let's say, bad news, or we see that the advancement is lower than expected. Because when there is revolution, the result is not sure, or the path for reaching the final destination is unpredictable. If you think at one of the biggest revolutions, the French Revolution, it was for democracy, but the first results that we observed was not exactly a democratic state. So similarly is what we are observing in transport. So we want to foster strong changes, but we need to be aware that it's not easy. And we need to pass through turbulent times in order to allow all technologies to work. So it means that we need to form skills and competencies at all levels. Technician, but also the population. We need to make it work multiple innovation altogether, and they need to talk each other. They need to be at the same level of applicability, at the same technology readiness level. We need to have a strong attention to what we call a societal readiness level, because if the society is not well informed, if they are not ready, also the technology and the technology evolution and the technology that we will see into the market will slow down. So let's say if our initiatives, it's well fitted in these scenarios. So this is the picture that most clearly depicts which is the structure of the MOST, and we can say that accordingly to the wish, we are treating several aspects that affect mobility, from the fuels to the infrastructure, from the management of the information to the management of the people, to putting at work different technologies that are coming into the market. Further, we are investing in infrastructure as required by the Competitive EU framework, and we are forming a lot of new researchers, which is the basic for preparing to this future. Going a little bit further, in the Competitive EU, there was written that it is necessary to consolidate. In order to consolidate this position, we need to work on specific topics. In the recovery plan, the Italian country altogether focused on 5 distinct initiatives. So in some way, we did our job accordingly to the request of the Competitive EU. The second aspect was to be committed over a relative long-term horizon, and the structure of the MOST and also the financing of the MOST has been thought in order to survive to the initial investment. So let's say we are here to remain somehow, or all of us have this expectation, and we are working to collect all the resources that are necessary to continue this experience and this research stream well after the end of the recovery plan project. And last, leveraging on University Alliance. And we can say that somehow MOST is like a national teams in football. So everyone have their distinct university and they behave, they have their specialities. But when they are in MOST, they behave collectively and they work for the same results. That is fostering the research in transport in Italy and having Italy as one of the competitive country in terms of new technology applied in transport. Concluding, if this one is not enough for convincing people that research is important, let's say go around the pavilion and you will acknowledge that the majority of the invention that happened from the ancient to today affected transport or are applied in transport. So we invented the wheel, and the wheel is still nowadays one of the key inventions for transport. We invent fire, and combustion is one of the key aspects for moving nowadays, still nowadays. There is a map, and mapping, understanding where to go and where to go easily is a core of transport. There is a plane that helps us to remember the first flight between Italy and Japan, that remember us that thanks to transport, countries are close together. Thank you very much.
Thank you, Paolo, for this great presentation of MOST and the ambition goals that we have to achieve. I'm pleased to leave the floor to my colleague, Christian Scervo, who will moderate this section, Sustainable Mobility, Safer Road, Less Congestion, and More Access.
Good afternoon everyone, and thank you for being here. My name is Christian Scervo, Business Development Management in MOST, and I'll quickly move towards our first roundtable, Sustainable Mobility, Safer Roads, Less Congestion, and More Access. This panel will consider 3 of the 5 aspects on which MOST is based: safety, decongestion, and accessibility. To address these issues and present MOST research outputs, I'd like to introduce Andrea Tonoli, professor at Politecnico of Turin, with user-adaptable powertrain with swappable batteries for urban lightweighting electric cars. Elisa Landini, expert and key figure at the University of Study of Modena and Reggio Emilia, infrastructure enabler solutions for new automated driving paradigms. Marco Fanfani, researcher at the University of Florence, A-Power digital twin platform for mobility and transport operation and planning. Ivano Lapaglia, postdoctoral research fellow at Politecnico of Milan, digitalization, safety, and capacity enhancement in the railway industry. And finally, again, Paolo Malighetti, full professor at the University of Studies of Bergamo, Mobility and Behind, Advancing Active Mobility Technology and Seamless Integration. Okay, I'd like to start with Professor Tonoli. Andrea, could you show us the result obtained from your research from the last 30 months and how they could contribute to for a decongestion perspective, please? I think we can start with a video.
So, please. So I cannot catch up with the speech to the video, so I just give a few words. So we develop a modular vehicle to address the needs of modern transportation in urban environment. We did this from the vehicle level to the powertrain level, including sort of what we think a novel battery pack configuration. So this is just a small overview, and then we can start the presentation. And yeah, this is, sorry. No, where is it? Okay. So basically, the starting point of our work is that the observation that the traffic congestion, lack of parking places, pollution characterize the urban areas today. And urban areas today are where most of the population stays. And by contrast on this, the cars that are offered on the market today are larger and larger, and their mass is steadily increasing. And we think that this is a trend that is in contrast with the need of the mobility sector. BEVs especially are increasing their mass, and as everybody knows, the mass is a primary factor in influencing the energy need of the transportation sector. This means that the OEMs that develop such vehicles have to spend a tremendous effort in keeping the energy needs limited, and also a tremendous effort in reducing the cost, which by the contrast is steadily increasing. So how can the research address these contrasting needs? How can we contribute to that? Our spoke is named Sustainable Road Vehicle, so we want to develop solutions that allow to tackle these needs. Our partners are University of Bologna, Salerno, Palermo, Cassino, and Politecnico di Torino, which I belong to. Together with this, we have also industrial partners that are main OEMs in Italy, so Stellantis, Iveco, component development like Pirelli, Snam, Teoresi, and finally Brembo. And our goal is to develop solutions for lightweight vehicles with a modular powertrain. So the solution we found, and with the solution we propose, is a vehicle with a modular powertrain that is tailored to the user. So the user can choose what configuration to adapt, safe and affordable. The vehicle can also be, or must also be, home integrated, in the sense that if with the widespread adoption of photovoltaic power generation systems, we want the vehicle to be integrated in the housing. And for this purpose, we think of a car, of a small urban car that can have a modular battery pack that can be configured in two different modes. One is frugal mode, where the user can install just one module of the battery on the vehicle, just to be able to travel in the urban traffic for something around 150 kilometers. and instead installing 2 battery modules, he can reach at around 250 kilometers that are what is needed for short extra-urban travel. This idea required the development of a new powertrain system, including a 6-phase synchronous electric machine with a dual inverter and a box which distributes the power among the two parts of the battery system. We work also on components of the vehicle, which are a very important aspect of all the vehicles today, not only our vehicle. And in this aspect, we specialized on regenerative shock absorbers. Here you can see 2 types of such shock absorbers. The left-hand one is exploits an electrohydrostatic transmission that converts the linear motion of the suspension in the rotary motion of an electric generator. And the right-hand one instead is a different concept. So we exploit a mechanical transmission with a planetary gearbox to convert the rotary motion of the lever that you can see on the bottom right of the figure into rotary motion, to convert again the motion of the suspension into rotary motion of an electric machine. In this, with such solutions, we can recover some of the energy that is normally dissipated in the suspension, just that amount that is needed then in the following phases to use the suspension as an active suspension to stop the roll or to change the load distribution on the different wheels to improve the vehicle stability and comfort. One part of the effort, comfort, is a human factor, and one part of our partners, especially University of Palermo, is working in exploiting these control capabilities in order to improve the comfort of the passengers on board. Another important component where we are working on are the tires, together with Pirelli, in the development of tires with more or less 40% less rolling resistance, and this is of utmost importance in urban mobility environment where the rolling resistance is a primary factor in the energy consumption. I hope to be able to stay in the time, and if there are any questions, I am more than happy to answer to you.
Thank you, Andrea. Is there any question? Okay, thank you. And so we will move faster to Elisa, and now we will see why. Please, Elisa.
Hello, everyone. Can we start with the video, please?
We are over 160 miles an hour average speed in an autonomous vehicle.
Fastest flyer. Yeah, this is the Unimore car, the team made up of an incredible amount of brain power. Unimore back out on track. Gianna, the name of the car. Unimore have been looking quick, been looking pacey.
Now here they come. Unimore coming to the line. They are going to win it. Unbelievable. They read their push to pass, used it to perfection.
So by exploiting the experience that we acquired in the Indianapolis Autonomous Challenge, that is one of the most important and challenging competition for fully autonomous vehicles, we got the experience to structure Spoke 6, that is cooperative and autonomous vehicles. So we mainly work on vehicles, and we identified three technological pillars of our Spoke. The first one is the simulation. So we simulated everything that we could actually recreate in a simulated environment. It means environment, it means for example, the racetracks or the urban environment. We simulated the vehicles, dynamics and the behavior, and we also simulated the sensors and all type of components. The second activity that is the most important one is the definition of the vehicle platforms. The vehicle platforms are the components that we need to turn a manual vehicle into an autonomous vehicle. It means sensors, actuators, connectivity, and HMI, the human-machine interaction. By considering the simulation and the vehicle platforms, we identified the public dataset, the dataset that we hope that could be reused and that are collected to create AI-based algorithms. But the most important part of the project, after defining and developing the vehicle platform, was to test them in a real environment. So we equipped the city center of Modena, that is in the middle of the Moto Valley, with right now they are 21 smart sensors, but at the end they will be 55. And these smart sensors are made of two components. The very first one is this roadside unit, is a sort of bridge for V2X communication to allow low latency communication via DSRC. And we connected this roadside unit with a smart camera that is able to detect roadside users, and with this AI-based sensor fusion, so fusing the data received from both parts, the smart cameras and the roadside unit, we can identify, we can detect and also track in the real environment, in real time, road users. So we use this smart sensor to allow new paradigms of autonomous driving. And we also created a digital twin of the same environment that is called MASA in the center of Modena Automotive Smart Area, that has been created to become the living lab of our Spoke. So we are testing the vehicles in this living lab, and we are using the digital twin to validate the feature and the functionalities that we have created.
Thank you, Elisa. Is there any question? Okay, so to remain about AI and digital twin and platform, I will introduce Marco Fanfani from University of Florence. Please, Marco.
Thank you for your presentation. So I will talk today about how to apply digital twin and artificial intelligence to solve mobility problem in urban environment. This is a quick video that introduces the solution. Okay. So the Optifast solution that is implemented on top of the Snap4City platform want to provide tools to address monitoring activities and tactical and strategic planning for the mobility of the urban environment. The idea is to respond to 5 main objectives that are the decongestion of the city by optimizing the road infrastructure, by identifying the most critical spots that cause congestion in the city, and so to reduce the travel time, the stop times, and consequently also the pollution of the city. Improve the safety of the city by producing early warning in the case of emergencies, so to activate promptly responses, and also to help planners to design more safer environment to protect vulnerable road users. To improve the accessibility of high technological resources to any city independently from its size, so to offer also to small communities and medium cities instruments to address the mobility problems. And this is possible because we want to promote a cost reduction of the solution by exploiting open software and a service-based business model. We can provide the solution to any city regardless of its size. And finally, we foster decarbonization because we aim to promote and to suggest a more sustainable way to address the mobility problem in the urban environment. So for this reason, Optifast is a scalable, flexible, and customized mobility solution that can be offered to any city, regardless from its size, from a small community to large metropolis. So the main 2 technologies on which we build Optifast are urban digital twin integrated with artificial intelligence analytics. A digital twin, as also my colleague speak about before, are digital entities that is aligned with the real world, that change over time. So in this case, a digital twin begins to be an entity over which the expert can observe, analyze the urban environment, and make experiment, compute what-if analysis to see what happened and which impact would have some changes over the environment. Real data are fundamental to create an high-fidelity digital twin, and for this reason, we are able to ingest several kinds of data. For example, measurement from IoT sensor, open data, geographical data, of course, and satellite imagery, data from onboard unit of the vehicles, data from the telecom operator to observe the movement of people. All this information is modeled and fused and made available to the operator, to the decision maker through dashboards and graphical interface over which the status of the city can be observed. This data is also exploited by data analytics based on artificial intelligence solution. In this case, the objective is to obtain simulation, prediction that can be used, for example, to perform what-if analysis on user-defined scenarios, but also to provide optimization that could automatically identify the best solution to specific problem. AI technologies include, for example, deep neural network, generative AI, graph neural network, also reinforcement learning. And in this way, the solution is able to support the traffic monitoring, forecasting, and reconstruction. It can evaluate and optimize the road infrastructure. It can provide a new traffic plan to reduce congestion or to prioritize specific travel modalities, for example, the public transportation. It can provide the travel direction with the routing and also analyze the behavior of citizens. For this reason, this Snap4City platform has been selected because it is an open source platform, completely open, and is able to ingest, to take any kind of data from any source and any format. So this is fundamental to build an high-fidelity digital twin and to allow to carry out data-driven analysis. Thanks to its modular architecture based on microservices, it can be scaled on different sizes and according to the complexity of the analysis that are required by specific cities, and is powered by artificial intelligence analytics that are built into the platform and can be accessed without any knowledge of programming skill, but simply by using the dashboard and interfaces provided. And for this reason, in Optifast, Optifast exploits Snap4City to create this new service based on a service-based business model in which each city can select which kind of solution has more interest for it. And with this solution, they were able to optimize the system, the transportation system, improving the efficiency, the sustainability, and in the end, the quality of life of the citizen. Moreover, being an open platform and being served with as a service model, we are able to reduce the cost of creation of dashboard, of control rooms, and also by speed up and make less costly the work of decision makers that have to analyze the city. To conclude, Snap4City Optifast promote efficient and safe urban mobility, contributed to an improved quality of life and the sustainable growth of the community. This has several social impacts that could be, for example, the reduced travel time and emission, greater accessibility to high technological resources, and improving road safety by providing early warning and a safer environment. This could provide traffic optimization, multimodal transport integration, optimization of public transport services, data-driven simulation for what-if analysis, and in the end, also traffic optimization for fuel consumption reduction. Thank you for your attention, and if you are interested, you can find some flyers and booklets over the desk down the room. Thank you.
Thank you, Marco. Okay. Is there any question? Okay. So surely digital instruments and digitalization generally is one of the key aspects that affects the mobility nowadays. It also affects one of the older system of transport. Maybe Ivano could give us an explanation. Please, Ivano.
Thank you, and good afternoon, everyone. So this presentation is about the role of digitalization in the railway industry, specifically with respect to the topics of safety and capacity enhancement. So if we observe nowadays, what's going on is that we are observing an increase of the demand for any kind of transportation, especially to be reliable and sustainable. And this is also true, of course, also for the railway industry. Therefore, this is put under pressure to deliver more, but in a safe and reliable way. And in this framework, digitalization is providing surely some possibilities to invest in the research. And in fact, the way we operate, monitor and maintain the railway system is significantly changing. For instance, digitalization can provide significant benefits in terms of safety if we think about the possibility of real-time condition monitoring system, as well as the possibility of implementing predictive maintenance strategies. And for what concerns the capacity enhancement as well, digitalization can be an opportunity for what concerns the adoption of smarter traffic management strategies as well as automation. So in the next few minutes, I will try to give you some insights of what we're doing within the Spoke 4. in these two frameworks. And let's start with the capacity enhancement. So the basic question is, how can we try to improve the transport capacity? And an easy answer would be, let's build new railway lines. But of course, this is not feasible for many different reasons, ranging from the huge amount of resources we would need, the time required for building up new railway lines, and also for the space availability which we don't have. So that's not the way we want to do that. What we can do is to try to see whether we can optimize the way we are currently managing the capacity of railway networks. And to do so, the first thing we need to do is to understand how we currently manage the distancing of each train along a single railway line. I'm using this simplified video where you see that basically the railway line, according to the fixed block signaling, is divided into sections of fixed position and length, and each of those sections can be occupied by one single train at a time. This way you can guarantee that there is enough space in between subsequent trains so that each train can stop in a safely way without colliding with the preceding one. But of course, this is far from being optimized. If you think what happens when a train is in between two blocks, both blocks are red, at that moment they are occupied. So of course this is safe, but this is not the best solution. So one possibility could be to move from fixed block to moving block signaling, which is a different technology that we know it works because it is, for instance, implemented in the new Metro 4 line in Milan. Of course, suburban lines are much easier to be managed than railway networks, but still this proves the technology to be ready and that could be exploited. Now, how does it work? Instead of having fixed block along the railway line, the block is moving together with the train. And here the key point is to know at every time instant which is the actual vehicle speed and the braking capabilities of each vehicle so that we can maintain the safe distance between each train at any time. And of course, this is the idea. We know that sometimes it works, but now we need to assess how and when it is could be powerful in the railway field. So we understand why we want to exploit the moving block technology. We want to verify the possibility of capacity enhancement, also with the possibility to discuss whether we could have faster recoveries from any kind of delays we could have. That could be, for instance, related to the passengers going up and down from the vehicles at the stations. And also what happens if we focus on the energy consumption, which is directly related to the driving style of the drivers. And this is the target, but how can we do that? We basically relied on simulations, both on fully virtual simulations and on the so-called hybrid simulations, where you have physical components, for instance, the onboard unit taken off the train, that fall inside the simulation loop to verify which are the performances of that specific component and to assess its behavior, for instance, in terms of issues with communication, time delays in the communication, and so on. And the expected benefits, of course, are the comparison of the performances of the two signaling systems, but that's just the starting point. Then we expect to be able to use the hybrid simulation to have time and cost reduction for everything that concerns the development, testing, validation, and homologation of new components, as well as the possibility to analyze the cybersecurity issues related to this kind of technology, targeting in the end the so-called zero on-site testing. So in this first part of the presentation, I focused on the capacity enhancement, and we understood that it is strictly related to the safety of the network. But anytime we talk about safety, there are many standpoints we can consider. And another I want to put your attention on is related to another project, which is associated to freight trains. So freight trains are currently being more and more used as a means for transport of any kind of goods. And unfortunately, these type of vehicles are quite poor from the point of view of the instrumentation you can have on board for a very simple reason. You have no power supply. So there's nothing you can do about that. We know that the companies, industries, and researchers are putting a lot of effort for what concerns the new freight trains that are trying to be more modern and technological, for instance, with the new DAC European project. But what about the vehicles that are already running along the network that should run for at least other 20 or 30 years? We should take care about those trains. And so our idea was to develop a simple, autonomous, and smart set of sensors that can be installed on board a vehicle to monitor its dynamic behavior during the service. And what you see in this short video is, maybe, let's see if this works this way, okay. It's just a small video that we took in the RFI San Donato test track, where we tested the monitoring system installed on the vehicle in a quite unique manner. So we purposely introduced some anomalies onto the vehicle, for instance, in the primary suspension system and onto the braking system, because we want to acquire data in those faulty conditions and validate our models and our algorithms so that we would be able to recognize those faulty conditions where we are in line. So this was quite unique, and this is just a sum up of how it works. So we performed these tests, then we set up our monitoring system. There you see an example of the sensor we developed. So we have some MEMS accelerometers, for instance, installed inside of that white box with a solar panel to provide power supply. And during that campaign, we tested the system and also validated the models and the algorithms. And so we basically realized a simple yet useful condition monitoring system to be used within the framework of predictive maintenance, targeting in the end the possibility of having safer trains, freight trains traveling along the network. So that's the end of my presentation. I hope you had some insights of what we are doing in this spoke. And if you have any question, I would be pleased to answer.
Thank you, Ivano. Is there any question? Okay, so we will go on with Paolo Malighetti. Paolo, to complete the scenario, we should take in account another transport system, probably the greener, active mobility. Please.
Yeah, thank you. So trying to let light mobility green is easier because it's already green. So the question for the Spoke 5, if the video can start, was which is the role of the bike in the mobility, and how to tackle this in an evolutionary way. Start. No, okay. So first, I said in the mobility and beyond, because when we talk about light mobility and we focus on a bike and the e-bike, we should be aware that they are not only a means of transport but also we use this vehicle for other purposes. So I'm not sure it started or not. It's working? Probably not. Okay. No. Let's see if the video starts, otherwise we will do without. Okay. So I was saying that when we talk about bicycle, we know that they can play a role in commuting because the majority of trips, 50%, are within a radius that can be tackled by bike, but also tourism and also sport. In Italy, more or less, we have 80 million tourist trips, and we have 100,000 people that are subscribed to the Cycling Federation, and more than 2,800 annual races played on road. So they are quite big numbers, so it means that we cannot neglect this role. So for this reason, we imagine to develop a solution that helps bikes to be usable in a more flexible way as possible by becoming even more greener. That means understanding which is the material, so basically carbon versus aluminum, which is the equilibrium, which is the best one in terms of sustainability, and try to have a vehicle that is as flexible as possible, and try to have a vehicle that can be a part of the ecosystem. So we have seen from the previous presentation that all the world of the mobility moved toward the autonomous way, communication, etc. And up to now, bicycle has been perceived simply as a vulnerable user, so like an obstacle to be avoided. On opposite, they can play an active role. So for this means, we try to understand and to study which is the sensors and the technologies that can be applied to bikes in order to have also bikes as a contribution for safety, for the safety of the others, but more specifically for the safety of the bike user, because he's a vulnerable user. So we focus on understanding how to avoid, how to prevent, how to quickly signal. All these things are reached by generating a set of laboratories that are focused on online mobility, which is quite rare. Because, let's say, as a minor type of vehicle, typically there is no infrastructure devoted only to the study of bikes behavior and bike technology. And during these 3 years, all the partners worked to put specific investment dedicated to bikes. From the vehicle itself to the engine. In the case of the e-bike, we rely on electric power because we don't need too much watt. So electric power is a good source and can be quickly manage the way of having only 100% green solution, because the energy provided by solar power is enough for them. And the last aspect is aging of the battery, which is a quite hot topic for a bike, because the battery is one of the main cost components for the bike itself. And also the real issue in terms of sustainability is the recycling of the battery. So if you can allow the battery to live more, we can grant for e-bike a good sustainability in terms of life cycle, not only when we use it. Then the user behavior, since we are talking about bikes, we cannot at the moment rely on autonomous and decision made by someone else, but there is what we call the human in the loop. So we need to account for the behavior of the people, and we need to help the driver. So what we are developing is technology that assists the driver instead of substitute the driver. And since we have a mix of energy provided by the battery and energy provided by the humans, we also have to find the right equilibrium and the right way to allow the people to provide their component of power in a healthy way, so in a comfortable way. So for this reason, we have a collaboration with the part that is related to the health behavior and to bike fitting, which is the prototypes that we are developing. So we are developing a bike that are, let's say, as flexible as possible. So it starts from a muscular bike. It can be transformed in an e-bike in a matter of a couple of minutes. It is foldable, or it is disassemblable. So you've seen in the previous slides a picture of the components that we have developed that allow the link from the rear part to the front part. And the idea is that we can bring both the fluid power and the electronic signals from the rear to the front in order to have a bike that is an e-bike, but is also completely unfoldable. Then we are working on the tires, and about the tires we are working on having materials that are up to 80% composed by recyclable materials, so bio-based materials, but also a tire with an ID that allow to the communication between the tire and the bike. We already have this technology in the car industry, but in bike, we have a very thin path of material, so putting inside a sensor is more challenging than expected. Finally, the work on the infrastructure, so we are talking about safety, and the safety comes from the vehicles, but comes also from the infrastructure, and we are specifically developing the project is already done in the video, that it was the drone monitoring for remote tourist lane, and also a set of instruments, helmet and over, that the user can bring with him when he drives, and helps the people to prevent and also to quickly signals in case of accidents or in case of drops. Those are the partners that I want to thank. All of them more or less work on a couple of activities, and they are all together. They are developing all I briefly explained it. And I also want to thank the private partner. They are I mean, not so present in these events, but they were present. They are present in the project, and they are contributing. In the case of Spoke 5, their contribution is alongside let's say the chain, because there are people that produce technology like Brembo for battery and brakes. There are Pirelli that they are helping us with the tires, but there are also Vaimo and Poste Italiane that basically they are end user, but they are providing their helps by clearing which is the needs and which is the requirements for granting a higher usability of the solution that we are developing. And let's say, just a couple of minutes, no, probably 1 minute to finish the videos, and that's all. Thank you.
Thank you, Paolo.
Participate, and also to the women. This is a strong part of the project, and we need contribution of all of people that have a good brain, and we need also the contribution of women. The so-called women in STEM is an important part of MOST, and let's take in the chance of these scenarios to say that also thanks to them the final project is more complete and is more successful. Thank you.
Thank you, Paolo. There is any question about the last speaker? Okay, so I'd like to... A question from me. Do you think there is any aspect that we, as MOST, could do to improve your activities, your research? For every speaker, please.
I can start. I think MOST can contribute in helping to extend the activity, because regardless that we have worked for 3 years, the research we did deserves an extension, and probably also an extension towards other collaborations. Specifically for Spoke 2, it will be very interesting to extend the cooperation to Japan industrial or academic partners, because I spoke about very compact vehicles. Italy and Japan probably are the two countries where such form of mobility was more developed in the past. So I think I am personally here to see if this will be possible through MOST.
For the for the autonomous vehicles, we definitely need to test them in different environments and perform pilots, large-scale pilots. Of course, in Italy, but we also to test the behavior of the users and in general, let's say the drivers, how they plan to use autonomous vehicles in future mobility. So it would be very useful and have a great value for our spoke to start collaborating with partners abroad, for example, in Japan, to start understanding how people can expect to use this technology.
Yes, I agree, because I mean, I'm more in the research part of the project and less in the project administration, let's say. But I think that having more test ground, more place, more contact with administration to evaluate what we have done, to test on the real playground, our research could be definitely useful. We have some test cases, but if we could have more with a good approach from the public administration, they want to try to use the tool to see if they effectively can work and solve their problem, could give us great feedbacks and can give the administration the initial step to take a new way to address the mobility problem, maybe. So increased cooperation, increased collaboration for the testing phase could be important.
First of all, MOST gave me the opportunity to become a researcher. I started with a PhD student. So I am one of those students who you always heard about that was recruited within the National Center. So first, he gave me the opportunity to start working as a researcher, and that was the past. But what about the future? My presentation was, I think it was almost clear that there is much work to be done yet. And of course, we're trying to set the roots for continuing the projects with European companies. So continuing the work is for sure what matters the most. And actually, for what concerns the Spoke 4, that would have been no better place than Japan, since this is the most advanced country in the world for what concerns railway transport. So I hope, and we are here also for that we can start some cooperations with universities and companies in this field. I think this is the best place to start.
So what to add? They already said almost everything. So Japan, as my first line was highlighted in Japan as a, let's say, kind of record in terms of public transport and also active mobility. And it's enough to looking around the city to see how much these two mobility forms, so public form, and the light vehicles are spread. Also, with different way of using. So, for example, I noticed that majority of people here use bike in a mixed environment with people that walk. On opposite, in Europe, typically bikers prefer to use the road, and they became, let's say, not the strong part of the meeting, but they are the vulnerable part. And what I also noticed is that sectors like light vehicle and bike and e-bikes grow dramatically, and a lot of company that was doing something else in the last 2-3 years start working and investing massively in bike and e-bikes. So we are also here to see which solution, which technology that was applied in other transport industry and in other industry can be quickly also applied to a vehicles like the light vehicles.
Thank you. Thank you, everyone. Surely, these are aspects very, very important. Strictly collaboration and cooperation between countries, between private and public sectors are fundamental to foster mobility sectors. Thank you for your intervention, and I'd like to pass for the other roundtable, where we will see the other two main pillars on which most is based, decarbonization and transition and work.
For our second roundtable, I am pleased to invite our professor for the section Decarbonizing Mobility, New Perspective in a Low Carbon Era. In this panel, we'll discuss how advanced material, energy system, and innovative technologies are helping to move toward a more sustainable mobility. Our guests today represent some of the most cutting-edge research effects of MOST network. And so I invite them to take their seat on the stage, and let's start with Alessandro Iafrati from National Research Council, Antonio Valenza from University of Palermo, Rosario Miceli, both to University of Palermo, Gian Giacomo Minac, Bologna University, and Dario Zaninelli from Politecnico di Milano. And last but not least, Marco Desiderio Loffredi Sinesi, Politecnico di Bari. Thank you. So, no? Okay, we can start from Professor. Yeah. From Professor Iafrati, yeah, will present innovation from zero-emission maritime transportation. Please.
Okay. First of all, I think I need an introduction, very few words to explain what is some dimension and numbers about the shipping sector. The shipping sector is, it was said before with the train and so on, that are important for the transport of freights, but of course 90% of freights worldwide. Oh, sorry, thank you. Okay, sorry. So I was saying, it was said, was discussed about the freight transport, and the shipping sector indeed is the one that is responsible for 90% of the total transport of goods and freights worldwide. And in Europe, at least, it is responsible for 13% of CO2 emissions. So it is a quite large component, but of course it's very important, this kind of service. The shipping, of course, is not only large ships for the freight transport, so it's not just container ship, but are also ferries that are important for our movement across islands, across the countries, and of course also for leisure or for yachts and, let's say, recreational activities. One of the limits in particular for the big ships is that this is one of those sectors that is called hard to abate, because it's very difficult to reduce the CO2 emissions in those sectors. In the Spoke 3 of the National Center for Sustainable Mobility, we have several partners. CNR is leading this, let's say, this Spoke, but we have also University of Naples, Federico II, University of Genoa, the University Partenope of Naples still, and University of Palermo, which is here next to me. And has industrial partner is Fincantieri, that is one of the leading industry worldwide for the production, mainly of cruise ship, but of course of many other ship types. Before going ahead, I want to specify another limit of the shipping sector. Whereas with automotive or with the railways, we move in the same country, for a container ship, it has to cross many different countries, actually continent, and you face different regulations, different development stages. And this means that when you, introduced, again, a transition in the fuel, for instance, it's not so easy because we have to be sure that along your route you find the bunkering that is easy, that can provide you the fuel that you are going to use. And this is, so it's a dramatic investment that has to be done at worldwide level, and this involves, of course, the IMO, the International Maritime Organization. But back to the research activity. So I think this introduction was important in order to give some specific needs of the sector. So, of course, we wanted to address the efficiency of the maritime vehicles, of course, reducing the pollution, and possibly to move toward the zero emission. For the large ships, it will not be an easy stuff. But then we have to improve the traffic management if we think about the port. And there is also another problem, differently from what we have seen, for instance, in the city, in Modena, or in the Lei. So the path is more or less defined. But if we move at the sea, let's say the route is not so easy because it's very three-dimensional. It's dynamics. It can be largely dynamic. So we need to know about the sea, the state of the sea, in order to take into account safety aspects, and also we have to think about the adaptivity to the climate change and to the new solution that the new condition that we are going to face. There is also another sector, although maybe it's easier in this case to achieve decarbonization, but it's the use of autonomous vehicle, and in this case, usually these vehicles are much, let's say, smaller, and then these are easier to be, if you like, electrified. But still, you need a lot of, let's say, sensors in order to know, to have a good situational awareness, and to have also, you have to develop also tools for the, let's say, to the guidance for the navigation and control. There is also another aspects that you have to mitigate, also the impact that you have on the marine life. In these slides, you see some of the points that we addressed, but it's, I wanted to focus, to concentrate everything in one slide, but it's not so easy. I start saying something. First of all, the first way to reduce the fuel consumption is to improve the efficiency. So to improve the efficiency means, first of all, develop tools to optimize the hull shape and the propeller, the efficiency of the propulsion systems, but also, when you optimize the propulsion system, you have to consider not only the chemical emissions, so the reduction of the reduction of the fuel consumption, but also the reduction of the noise. And this means that you have to avoid the cavitation occurrence. In order to reduce the friction, again, the fuel consumption, you have to reduce the friction, and this is the way. The reason why we develop solutions for the coatings, and in order to have a surface that is to which the friction is lower, and also it's more resilient to the formation of fouling. Again, in terms of efficiency, there is the efficiency in terms of the electric apparatus on board. In particular, if you think about a cruise ship, in a cruise ship, which is, something that can host about 5,000 visitors each time, about half of the power is spent in the other loads, and then there is much room for improvements in the other loads rather than in the hydrodynamic loads. Concerned with the propulsion system, there is, let's say, it will not be easy for large ships to move toward electric or fuel cell solutions, but at least you can start using combined fuels, so using the typical diesel with the methanol or other, possibly also with hydrogen. Of course, hydrogen has to be green hydrogen, the fuel cell can also be used for the auxiliary system. So even if you do not use this for the main engine, you can use this for the auxiliary systems, which are a lot. Sorry. For the autonomous vehicles, as I said, we are developing solutions for the coordination of the vehicle, and in order to to coordinate better and to use in a better way the energies in order to monitor different parts of the, if you like, of the sea bottom, or also to coordinate different vehicles when you are at the port. Digitalization is, of course, a masterpiece of essentially all the activities. So this is even for the shipping sector. You want to digitalize the system, the different systems, starting from the dynamic of the vehicle, because as I said, when the vehicle moves in a rough sea state, the situation can be very serious, and you can have a lot of safety issues that you have to take into account. As a part of digitalization, it's something like what has been done in Modena with the MASA Center. What we have done in the within MOST is a digitalization of the Gulf of Naples. In the Gulf of Naples, we have installed many sensors in order to monitor the sea state, the currents, the wind, and all the, if you like, the meteo-ocean conditions, and start to have a sort of forecasting system, short-term forecasting system. And this is, when you integrate this with your digital twin of the ship, then you can have a weather routing system that help you, first of all, to use the most efficient way, so to use the path that is less affected by the high sea state, but also to go where there are less currents, or at least the currents are in favor of your ship. And again, if you account also for the wind, for instance, there is a tendency today to install sails on the ship in order to get favor, and then in this case, the weather routing system can take into account also this aspect. I want to close just to say one aspect. In the shipping sector, investments are quite large, and usually the ship lasts 30 or 40 years. So before doing an investment, you need, sorry, this was the stop. You have to do an investment, and then you need to know what is your return on investment, your OPEX and CAPEX. So all this is a part of the spoke tree. So in this spoke, we do not study only the technological aspects, but also we take into account these economical aspects, because otherwise the companies or the industry is very reluctant to invest. Thank you very much, and again.
Thank you, Professor Iafrati, for this insight, and also for keeping in mind the match from research with the necessity and the background from the industry that is our part of the public and private partnership. Let's move on to Professor Valenza, University of Palermo, and we talk about natural materials and their role to enabling the innovation for the low carbon mobility.
Thank you very much. Let me first thank the organization to be here and give the opportunity to speak about our project. I just want to show some aspect that we are involved in this kind of activity, meaning we have a problem regarding essentially materials. And in particular, I want to just to focus something about the natural material, which are, in my opinion, the solution for the really use of future. And then we have tried to find some spatial analysis. So to this material, I want to report the results what we have obtained. In particular, the transport you see is the goal for the application of this material, because they have very many facilities, but also a lot of problem. And in particular, I want to focus my attention about the principal problem that have the natural material, which is the humidity. And then we have start with a very long study to this in order to find a different way to solve the problem of the using of this material for application, in particular when humidity of water is essential. And then we have studied the problem of the humidity in the natural material, because the natural material are essential porous, and then they are like a sponge. And then the water goes inside, and then the swelling, and then the properties are reduced. And in particular, one problem that we can have tried to solve this problem is hybridization, meaning to find some skill, some particular the material in natural. In particular, we are focus our attention with something which is obtained also from natural material like basalto. And then we have done the like sandwich structure, in which inside there are natural material, outside this protection, like a sort of new opportunity for using natural material. But we have conducted a very intensive study about the study of humidity and then the humidification of this material, and in particular the comparison with the natural material, which in part are to recovering the properties. And you see in the picture, like it's the quantity of the properties can be recovered when the humidification are done. And our study find that the hybridization you see in the last picture is something which is able to can obtain results that are similar to the materials which not have problem, like synthetic material. And you see the blue area are similar to the area which are involved the materials which not are good for this application. And then this was, in my opinion, extremely interesting for the future of the application of the natural material. I want just to spend, which I was, I don't know why I have another picture, maybe it was in the last presentation. I want just to explaining the other solution which I have in Palermo with the most. One is involved the use of LCA approach, and the other one is related to the use of some anti-fog. And then, because in Palermo there are two groups which work in this, also in this area, maybe there is another presentation which I be made. For me, it's okay. Thank you.
Thank you very much. Are there any questions? No? Okay. So we can move on, and we talk about on hybrid powertrains and new propulsion with Professor Miceli from University of Palermo.
Thank you. First of all, me too want to thank the organization, Emblema, in the name of Tommaso Aiello, for this organization, the Hub, of course, Claudia and Christian for this fantastic work they have done previously. Since months of work, I know that there was a lot of effort, and we are very happy to be here in this Italian pavilion that is very, very beautiful. And we said, we'll read this morning that there are a lot of journal announcements that this is one of the best pavilions in the Expo. But I want only begin to speak about the 12 spoke, to spend some words, and I was very lucky to work in a lot of spoke of the most community of the center, and I have to say that some words that Professor Malighetti spoke some minutes before, the importance of education and innovation. This is why most, I think, is very important, because teach us how to work together, so to enlarge the education of young people and to work together with industries. We are used to work university with peer-to-peer with one industries, but now with most we can use to work more university with more industries. And this is very important to have a good improvement in the innovation. Innovation that is very important, that it means that we need more education. And we have to say that at the moment, education is not a focus in our nation. And this is why I'm not so happy to this, because universities are now growing down. Money for the university are not so as usual. And then I have to say that we are in a, most is focused on some very, very important subject like sustainability, green transition, but at the moment European Union is a little bit less aggressive in this field. So we have to push up strengthen our effort to remove this and to go to make as much as effort we can, all the community of researchers and of industries, to go inside to make more strength in green transition and sustainable. But let's speak about this 12 spoke, because we are here to explain what we've done till now, but we are not at the end. We have 1 year more to this very important nation. Japanese, like a researcher before me told us that is one of the most important nations in the field of mobility. We saw in all town that we were in Japan that mobility is very, very well organized and very well announced. But speaking about Spoke 12, that we are involved in high efficiency, low carbon mobility solution, of course, enabled by hybrid powertrains, digital connectivity, and hydrogen-based propulsion technologies. Our spoke, in very few words, aims to create a network of research and laboratories, large-scale demonstration environments, full-scale prototypal application to achieve the following goals, like innovative propulsion, of course, because this spoke is, I say, worked with a lot of other spoke, with water, with spoke 3, with spoke 2, with spoke 13, and so on, because propulsion is one of the subjects that go in all the field of the mobility. With e-bike, of course, that are very, very important. We have some scalability project on this. And So we want to go in the field of innovative propulsion technologies powered by sustainable energy for each sector of the transport system. So it means naval, air, and road. Identification and railway, of course. Identification and prototype development of disruptive solutions for advanced and sustainable powertrains. Development and demonstration of energy conversion processes and technologies for fuel flexible, like e-fuel and B-fuel powertrains, and identification of methodologies for the optimal management of energy flow on board applicable to land, naval, and aeronautical mobility. So the organization of the spoke in work packages is, of course, the work package 1, like all the other spoke, is coordination and management. Then we go on the spoke 2, that on the work package 2, this is ground propulsion, air propulsion, water propulsion, that are organized with spoke 5 in virtual integration and LCA of all these kind of propulsors. And of course, the last work package is communication and dissemination, and this is one of the moments in which do this job. Our group in Spoke 12 is organized, of course, in synergies between companies and research institutions. Going from the north to the south, we can see that we have ICMate in Milan, in Padova, University of Unimore from Modena, then STEMS Ferrara, that is with STEMS of Napoli, it means CNR, of course, University of Florence, SNAM, University of Palermo, and Avio Aero. And the spoke leader is the CNR STEMS in Naples. Bianca Vallejo, that thanks all of you, of course, but she couldn't be here with us and sent me. So, what are the pillars of the spoke? Of course, to reach innovative propulsion, we go in 3 branches: methodologies, technologies, and fuels. In methodologies, we organize advanced laboratories, of course, by infrastructures. Innovative numerical tools, it means new simulation approach, unconventional and advanced experimental techniques. In technologies, in this branch, we reach some new architectures, smart sensor, of course, new components, and we work in advanced materials, as Professor Valenza told us, because are not only in the naval, but in all kind of mobility prototype. Then fuels, of course, that it means carbon-free biofuels, CO2 neutral, and hydrogen, methanol, biomethane, and e-gasoline. At the moment, I want only we have a lot of prototype, a lot of as example of this research, but for the shortness of the time, I have only 2 examples of this research. Of course, I sent a long version in the site. You will have more precision words on what we are doing. One of the most important research activities in multi-phase drives that are gaining now in the scientific and industrial community very big attention, because they are fault-tolerant capability, lower torque ripple, lower magnetic induction field space harmonics, power splitting. And between the multi-phase drives, we choose 6-phase electrical powertrain that, as Andrea Tonoli told us, is using in his 500 car, or in some other prototype powertrain system, because this represents a techno-economic compromise with respect to other types of multi-phase system configuration, and this is a figure of the test rig that we have in Palermo University. Then another very important prototype was organized in the flagship Retrain, hydrogen engine track, e-engine track and infrastructure. This is a flagship project of the National Center for the Sustainable Mobility. This flagship is powered by CNR STEM, Iveco Group, SNAM, FPT Turin, Cubogas, Green Tour. And they, you can see in this figure, working on H2 engine, vehicle integration, electrical and electronic software, wheelbase adaptation, after treatment system, and hydrogen storage system on a track. First proto vehicle equipped with I2 H2I CE are now working. Dedicated testing facilities, STEMS and FPT Turin are doing now. Dedicated technologies for H2 modular compressor, of course, that needs for inlet the hydrogen in the truck, and methodology for risk assessment and safety analysis on HRS. And this is last picture in which I want to see you how the truck, the normal, the Iveco S-Way MY24 42 tractor has been changed from the main component of a diesel truck to a main component of H2 ICE truck, in which you can see the engine, the gearbox, the prostaff, the rail head, the fuel storage system, the cooling system, and so on. And this now they are working to have all the demonstrator, this demonstrator to have all the data to the safety and to the economical aspect of this project. Thank you.
Thank you, Professor Miceli, for this overview on Spoke 12. And I take your input to speak about education and move to another pillar of most objective, which is transition and work, and leave the floor to Professor Minac from University of Bologna that discuss on how we can educate the future engineering.
Okay, thank you. First of all, I'm partially in behalf of Professor Leila Ceschini, who is the Spoke leader of Spoke 11, and partially because it's my activity is related also to education, to how to use the legs we have. I mean, the ideas need the legs to walk, and we have many legs available, young legs that are our students. So how to involve them into the projects. First of all, I provide you a very, very short introduction on Spoke 11. Spoke 11 is about innovative materials and lightweighting. So it's a very horizontal spoke. We use material in any possible application, of course, in mobility. And why lightweighting? Because if we try to make a life cycle assessment of any possible item related to mobility, we see that the weight is the most important thing. So, of course, if you make something in carbon fiber reinforced plastics, the initial carbon dioxide produced will be very high, and possibly it will be hard to recycle, but it's not true actually. But the carbon dioxide you save during the life is of many order of magnitudes higher than the one you produced by doing the manufacturing the component. So this is the real point. We focus on innovative materials, of course, as regard sustainability and at the same time, we want to improve performance using circular economy in a multidisciplinary approach. All of these keywords were used in there's audio also. I didn't know about that. In several projects we made in the Spoke 11. At the beginning, the projects were aimed to what happened? Okay, it's better to take out the audio, not to come back. Yeah, they were aimed to apply different materials and technologies. For example, in the structure of the work packages of Spoke 11, we have a focus on different material classes. So ferrous alloys, non-ferrous alloys, so especially aluminum and titanium, and then polymers and composites. And we have also a transversal work package about optimal design. So, for example, topology optimization, or in general, design optimization. So we made several closed calls to apply different technologies for different prototypes. In the pictures here on the top, you see hybrid solar and hydrogen car, and of course we need to optimize the material to obtain a safe case for the hydrogen propulsion system, because the car is driven by students, so we care about them. And in the second case here, you see this solar vehicle as parts that were manufactured using molds made out of recycled carbon fiber. So in these days there are discussions in the European Parliament about what to do with carbon fiber, because it's a hazardous materials or not. What about recycling? We near Bologna, in Imola, we have a recycling plant, this private recycling plant, but we collaborate to this, and we are already using recycled carbon fiber for these applications. And in the same vehicle, we applied components, for example, the pedal of the brake made by long fiber reinforced plastics. So also they were optimized from the topological point of view. All these projects were then showcased and applied in real life in competitions. Thank you to the flagship Line A program, where we won the project Green Wave and later Red Wave in collaboration with Spoke 2 and Spoke 3, because we developed both road vehicles and boats. And in this framework, we participated in a competition for students in South Africa. The competition goal was to go from Johannesburg to Cape Town, which not in the shorter way. It was about 2,400 kilometers on solar power. And this is very interesting because in this case we saw students participating from the designing of the car, the manufacture, and also in the winning the race, because we won at the end. Another important thing is that in the some students patented the rear suspension of the car together with the personnel of the University of Bologna, and this system won also the BMW Innovation Prize in the same competition. Something similar happened for the outboard motor that you see. It is patented, the part that you see, by a group of students and a couple of professors as well. And we took part in the Monaco Energy Challenge last year, and we will go as well this year. It's a competition for boats that are either electrical or hydrogen powered. Last year we participated with a hydrogen boat. This year we will participate with a hydrogen boat and this electric dinghy with all the powertrain was developed by our students. In the QR code, if you are able to take the picture, you will find the links to videos about the competitions and where it's there's a possibility to see all the story. I think that the students are students mostly of mechanical engineering. Okay, we're not limited to these students. Sometimes we have students also from other branches, let's say management engineering, economy, sometimes communication. So it is possible also to extend to other kinds of students these activities. Of course, I'm more interested in engineers because I'm the Master of Science course coordinator in mechanical engineering for sustainability. So we are right in the right spot. Thank you for your attention.
Thank you, Professor Mina, for this overview of different projects and for the strong engagement of students. Now we move to Professor Zaninelli from Politecnico di Milano, who presents research on electric traction and traction system and batteries. Oh, there is a problem with the... Oh, okay. Doesn't change there. Okay, now it's work.
Okay. Thank you, Claudia. Thank you to all the participants and the organization that host us in this Italian pavilion. The Spoke 13 deals with batteries and electric traction. And the research we performed during this period in the Center of the Sustainable Mobility were concentrated in these two aspects, main converter batteries, but also in the way to supply converter and batteries for the mobility. The first picture you can see in the frame deals with the possibility, the experiments we did for the wireless power transfer, in a way that you transfer the supply of the car by means of the what you call the dynamic transfer of electromagnetic power transfer. We had a circuit of 1 kilometer length close by to Milan, where the wireless generation for magnetic transfer were put under the asphalt, and the receiver on the car and on buses, some experiments were made in order to measure the performance of the transmission, and in order to check the possibility to supply the system in this way, also the electromagnetic fields and the safety of the person on the car, also with the possible electromedical devices for the heart. This was one part of our study. The second part were concentrated in motors and converters, or better, electrical machine and converters, and batteries. In the history of the electricity technology on board of the vehicle, two are the goal that we try to reach during the history. So reduce space and reduce weight. In this case, you can leave more space and more weight for the passenger or the goods, so for the goal or for your transportation. So we study some converter in order to reduce space, but taking the same performances, and also the same for the electrical machines. Concerning the batteries, we study different kind of materials, chemical materials for batteries, and also how to check and detect the status of the batteries for the reuse of these batteries, or for to save some components for possible different stock of these components and this material, in order also to save the environment. We did our study in collaboration with some industrial companies. In the group of university, we have not only the Polytechnic of Milano, where I belong to, but we also have the University of Modena and Reggio, University of Bologna, the University of the Polytechnic of Turin, and also the University of Cassino, the University of Rome, La Sapienza, and the University of Pisa. So we have 8 universities, and also 7 industrial companies. We worked together in order to reach these results. Also in some financed project inside to the BOST, because we need to apply our study to some real cases. So this was our study, our work during this period, and that's is in summary, in a short summary, what we did in this Spoke 13 that I have the privilege to coordinate. Thank you.
Thank you, Professor Zaninelli, for your strong effort in cooperate with the private and the public sector in populate Spoke. Now, last but not least, our younger speaker, Marco Desiderio Loffredo Senesi from Politecnico di Bari, will talk about the project HyMob on modular fuel cell.
So, good afternoon to everybody. Yes, I guess I'm the youngest here. So I'm grateful to be here, to have the opportunity to talk to such a wonderful audience. And also I'm liking very much Japan and everything it has to offer. So I will talk on behalf of Professor Vito Di Noto from University of Padua, Professor Enrico Negro also from UniPD, and also from the group of Polytechnic University of Bari, and I'm doing my PhD there. So Professor Marco Torresi and Professor Michele D'Assisti. So now we'll talk about fuel cells. proton exchange membrane fuel cells. These devices are quite interesting because they have something in common with both hydrogen internal combustion engines, but also with electrochemical batteries. So they have, from the first ones, they are open energy conversion systems. So they require streams of, for example, hydrogen and oxygen. We have a conversion and we can produce power. What they have in common with the second one is that they are not based on combustion. So like batteries, they are based on electrochemical energy conversion. So we start seeing a bit of aspects. So first of all, I'm talking about the results of the project called Hydrogen Mobility Made in Italy, short HyMoBitaly. So University of Padua and Polytechnic University of Bari are the two partners that worked on this project. So we want to work to proceed towards an efficient made in Italy proton exchange membrane fuel cell stack operating on pure hydrogen and oxygen at high back pressure according to a Lego-like concept. So we start by talking about the activities of Polyba. So what are we doing? We want to develop a power system composed of multiple PEM fuel cell stacks, which are electrically, mechanically, and thermally interconnected. So first of all, PEM fuel cell stack, why? Because single cells produce so low electrical power, we need to connect multiple of them in series in independent units, which are stacks like this one. And we might also connect multiple stacks together in a multi-stack configuration like this one. So why do we do this? Because we want to promote standardization of base units, want to aid industrial scalability in manufacturing, and modularity in hybrid powertrains, because we want to fit this kind of devices in hybrid powertrains. So what we did was just we designed a modular system with also modular pipings. We used some polyoxymethylene framing for electrical and thermal insulation. We have some chrome-plated brass pipings for the circuits of hydrogen, oxygen, and the coolant. And we have also some flat cathode outlet circuit to avoid condensation and flooding of this circuit. So we did some testing. So first of all, some activation procedure. This is done in order to clean up the stack and also to rearrange the materials from the manufacturing stage to a morphology which is more suited for operation. Then we tested by a galvanostatic polarization test procedure. So different flow rate of fuel and oxidant, so different current levels and resulting voltage and power levels. So the result that we obtained by comparing, for example, the single unit and the Lego-like oxygen hydrogen unit, we are of a very, very close electrical efficiency. This is very important because it means that we can scale from 1 to 2, 3, 4 or more, of course, limited number, the power with a minimal loss of efficiency. Indeed, we have, let's say, a Lego efficiency, a combined efficiency of 0.99. So 99%, it's a good deal to have only a 1% loss in power and efficiency. So, okay, so this is shortly the video. I don't know if, yeah. So basically, we have simply, okay, stop. Don't worry, it was not essential. We can just skip to the second part where we talk about the work by University of Padua. So what happens is that at both electrodes of PEM fuel cells, we have electrocatalysts. These are essential, as in battery, the electrocatalysis, because we want to speed up the reaction. So differently from batteries, here the reactants and products are not constitutive parts of the devices, but they are provided and discharged. So usually on the cathode side, the oxygen reduction reaction, the ORR, is the bottleneck, is a key bottleneck in PEM fuel cell operation. Usually we use platinum on carbon electrocatalysts. These are very expensive. So Unipd synthesized novel core shell electrocatalysts using platinum but in a much smaller amount and having better performances than commercial platinum on carbon alternatives. So what they do very, very briefly, they prepare some precursors with source of nitrogen catalyst, platinum, and co-catalysts, which are transition group metals such as copper and nickel. And we have some support of carbon, and eventually some templating agents. So they have a multi-step pyrolysis, so heating in absence of oxygen. We have pristine core shell electrocatalysts, and then an activation procedure to have the electrocatalyst powder. So they prepare basically two kinds of electrocatalysts, one with copper and nickel as co-catalyst, and the second with only nickel as co-catalyst. And we can see here that we have a certain weight percentage of platinum, which is very similar to this 40% in weight percentage of platinum, of the platinum carbon commercial benchmark. So we have quite similar composition, because we have only a limited amount of weight in nickel and copper. But what we see from testing is that both these two electrocatalysts by UniPD will guarantee a better kinetics and enhanced durability upon ex-situ accelerated aging. So the most relevant aspect is that they can guarantee these performances, for example, in feeding with hydrogen and pure oxygen, better performance with lower utilization of platinum compared to the conventional electrocatalysts, so up to 14-16 kilowatt per gram of platinum versus 3-8 kilowatt per gram of platinum of commercial electrocatalysts. And they were also able to achieve like 2 grams easy batches, so each is sufficient for 5 to 10 kilowatt of PEM fuel cell stack. So these are two sets of activities that we have seen, one by Poliba and the other one by UniPD, and both these set of activities are working towards a better PEM fuel cell system, more modular, easily to be integrated within hybrid powertrains, but also with lower costs due to novel electrocatalysts. So I would like to thank everybody for listening to me, and I'm done. So.
Thank you, Dr. Senesi, for your presentation. And as Christian asked before, also for you, a brief question about what could be the added value for your spoke or your research in collaborating with universities, research centers, and so on in Japan.
Okay, so as I said before, I'm grateful to be here at my quite young age, and it's very important to present these kind of activities in Japan, because Japan is at the forefront in the development of such interesting, novel, and really sustainable and helpful technologies for sustainable mobility, such as hydrogen power, hydrogen conversion for mobility. So it's very interesting to be here in the country where like Mirai was invented, and or a lot of research is going on for the future of the mobility. So I just want to add that we would be glad from Poliba, from UniPD, to keep working on this topic. And so all the professors that I mentioned before are glad that I'm presenting here actually. But we also want to keep working. So we would like to maybe to achieve some funds in some way, to then basically push our work forward and do other advancements. So it's that's all from my side.
Thank you. Professor Zaninelli.
Thank you. Concerning to my point of view, the SMOST, it's now a big center of coordination and collaboration between the universities and the industry. One of these industries is Hitachi Rail, that is Italian Hitachi Rail company. Hitachi is a Japanese group, so we have already one connection with this important country in the field of technology for mobility. For my point of view, this presentation that we had the opportunity to do in this pavilion in Japan offer us the possibility to be known also from other industrial or university in this country, to increase our collaboration, our study together. We, in this case, in my spoke, we sent to University of Tokyo one PhD student that spent some months there to study in this field of the new converter for the mobility. And this opportunity of today is the opportunity to increase this work of connection, and I hope the MOST can give us other opportunities as we planned for going out of our country, going in the world to be one of the centers that can compete in the world in this field of the sustainable mobility. Thank you.
Thank you.
As regards materials, and especially from my point of view, Japan is very important because who knows me knows that I work mostly with carbon fiber reinforced plastics, and Japan is the hometown of carbon fiber in several ways. Moreover, when we try to find excellence, we find always Japan in the middle, because, for example, for the solar cars, we use Bridgestone tires that are made for the application, and there are no other tires with those characteristics. And I have a memory of 10 years ago when I started dealing with solar cars. Before starting, I was talking with my colleagues who had some experience, and they had always one reference team that time. It was Tokai. And so I grew in my experience with solar cars with this name in my mind, and now his professor is here, and so I think we will start collaborating.
Okay, thank you. Very few words because perhaps I spoke too much before, but of course I think in my opinion that in the thinking of most that want to collect education and innovation, disruptive innovation as industrial people want to say, I think that being in Japan, that is, as all of us say, that is one of the most important in the mobility fields nation for the universities. So they are very big universities, very important university. I know a lot of professors here in Japan, in Tokyo, Nagasaki, in Osaka, and we know that they are very, very focused on mobility and industrial, of course. I invited one of my friends from TMEC, that it means Toshiba Mitsubishi Corporation, that is one of the most important industry in the field of energy, of course, but not only strictly in energy, but even in mobility and so on. And we are making some connection between us, but I want to enlarge the possibility to work with this big industry, not only for University of Palermo, that is not important, it's important with all the center, all the most that can work with this very high-level university company, and so this, I think it would be a good opportunity to share with all our colleagues these possibilities. Thank you.
Thank you.
But in my opinion, it's Expo also important, because we have inspiration. You see also the the pavilion which are especially devoted in this sustainability. So in my opinion, it was for me just an inspiration. I'm really very happy to be here just to have with me this suggestion and put my idea new in laboratory, in our laboratory. Thank you very much.
Thank you. I mean, it was said before about automotive, railway, but also in terms of maritime. If you think about Italy and Japan, they are elongated. Of course, Japan is longer and bigger, but anyhow, the maritime transport is fundamental. And so, in this sense, we have already some collaboration in place. I mean, there are already, I don't know, maybe 10 years, something like that, with Yamaha and Fluid Techno companies. And also with others, and we have several collaborations since many years with different universities here in Japan. Of course, we could do, I mean, we are in condition to do much more than before, and in particular, maybe to do something different than before, for instance, on digitalization and on new fields that, whereas maybe up to now, we were based on, let's say, some traditional topics, whereas there is the opportunity, thanks to this development we have made, thanks to MOST, to open and to try to establish collaboration on new fields that we have developed together within this National Research Project. And I hope this will happen soon. Thank you.
Thank you. Thank you to all the speakers, professors, and guests for your presence and your contribution. Thank you for Fondazione Emblema for the organization of the Italian pavilion and these projects, and to my colleague Christian Scervo for his work on this topic. And now we are closing, and let's continue to connect research with the real impact and the real world, and move together through the greener mobility solution with MOST for better life and for people. Thank you.